Okay, let's start with the master coordinate system. The goal of a master coordinate system is to create a coordinate system on the CMM that duplicates the CAD coordinate system, regardless of where 000 is, be it on the part or be it out in space somewhere, if the file is in car body or aircraft coordinate system. The coordinate system is created from measured features, and then the origin is rotated and translated to be identical to the CAD coordinate system. Where all the datums converge to a single point will most likely not be 000, especially if it's in car body or aircraft coordinate system. However, this point will be at perfect nominal, whatever the XYZ coordinates are of that particular convergent point. So let's go take a look at the master coordinate system. So the part that we're going to use today is an automotive part, and if we zoom out you can see that 000 is not only not on the part, but it's way out in space there. So we're going to be using this automotive part for what we're doing. Now the next thing is I've already created some measurements on this part for the first segment that I have open, which you can see is the master coordinate system, which is what we're going to do first. But I used these exact same measurements and copied them to two other segments for use with our other coordinate systems that we're going to be discussing later, just so that we're using all the same features for everything. So as I said, I've already created the measurements for this master coordinate system. There's a plane on the main surface of the part, and then the large hole is going to be my datum B, and you can see there's two small holes which we have a constructed line between, and that's going to be my datum C. So let's go ahead and make this master coordinate system. We select master coordinate system from the construct ribbon, and then we go in and select our datum labels, MA, MB, and MC. Then we can hit enter, and then we're prompted for saved or temporary. We always want to select saved in case you want to recall it later in the program. So first off, you can see that we have a master coordinate system now created at the bottom of the segment. And you can also see it graphically on the part at the origin of that big hole. Let's rotate the part around to get a better look. Notice that the yellow checkmate XYZ triplet that's on the part is at the same orientation as the triplet of the CAD geometry. Now let's zoom up on the origin hole and take a closer look. Let's put another circle measurement on that origin hole and make sure that it's after the master coordinate system, and then we'll take a look at the XYZ nominals of that hole. The XYZs of this origin hole are not at 000, but rather the nominals that they're supposed to be in this CAD coordinate system or car body. So let's output this segment now, and let's take a look at the code that gets created. If we scroll down to the bottom of the program where the master coordinate system is, you can see that after the origins are defined, the coordinate system is rotated. In this case, about X, Y, and Z, followed by a translation in X, Y, and Z to get the CMM coordinate system to be identical to the CAD, in this case, car body, coordinate system.